Hi all. I'm José Luis Ledesma from Social Point. I'm a systems engineer. For those who doesn't know Social Point, we make mobile games, Dragon City, Monster Legends. Also, we are hiring. Check it out if you're interested. There is a systems engineer position right now. I think there is not yet published, but it's there. My Twitter, my email, you can reach me out if you have any doubt or whatever. So let's start. The agenda. We will start explaining how our infrastructure started, how it grew, how it go out of control, especially on integration and development style environments, and how we solved it. We finally will make a demo, hopefully successful demo. So the beginning. As a lot of companies quite some years ago, and quite a few right now, we started with a LAMP, Linux, Apache, MySQL, and PHP. The development was done in the developer laptop. The developer just touched some code, pushed it to the server for QA, integration, whatever. So each time a developer needed to push the code to the server, we share the same Apache server for development and the same MySQL instance. So they needed a new virtual host and a new MySQL database, or just a folder in the document root and some tables, whatever. But it arrives the day that the developers comes to us and says, we need to implement a new feature. We need to make a leaderboard, we need to set up some offers, raise a status to track a status of arrays. So we decided to set up arrays. OK, now each new development environment needs a virtual host or a folder, a MySQL database. And instead of setting up a Redis instance for each new development environment, we decided to just pick up a prefix for the Redis keys. So each environment uses a different prefix, so there is no collision in the Redis keys. Well, then the next day, the developer comes again. We start each other. What? We need a new feature. Hey, you have a Redis. No, I need full text search. OK, let's set up an Elasticsearch there. So now each development environments need a virtual host, a MySQL database, a new prefix for the Redis keys, and luckily, Elasticsearch, when you post new data to a new index, it gets created. So it's easy. Each environment just posts data to a different index name. It arrives a day where MySQL, it's a pain in the ass in production. We have virtual shards, we have sharding, we have resharding, we have to scale up manually, error-prone, painful, slow, and it's almost impossible to scale down all this setup. So we decided to go to DynamoDB. What happens now with the development environment? Now we need a new virtual host, the Redis prefix key, the Elasticsearch index, and with Dynamo, we can create a new table for each environment. We can have a column for the environment. We decided to go with a new table for each environment, but it's hard to scale. But, well, it works. The developer comes again. We hate each other already. So we need to make connection persistence. We need WebSockets. We need a chat. We need to push data to the clients. We need a more responsive game. So we have decided to develop a Golang service. OK, new development environment, new virtual host, new DynamoDB table, Redis keys with its prefix, index for Elasticsearch, and what do we do with this new service in Golang? We decide to run a binary for each environment. So we have to select a port to run that service. We have to open firewalls. Well, it's a mess. But things continue to evolve. So now there is not just one Golang service. There are more than one. We need a game configuration management because game designers and level designers need some way to tune up the game configuration. Also, we need live ops. We need to set up features to schedule features, to enable and disable in some time. We need to do an A/B test, a lot of things. So, new development environment, it's a virtual host with the DynamoDB table, the prefix for the ready keys, the new index in Elasticsearch. We have now multiple binaries on different ports that we have to manage, and also the configuration management application and the live-ops management applications needs to know about this new environment. Well, that's obviously doesn't scale. So I have a dream. Imagine that you can create a Git branch, push it to the repository, and you have a new run environment for you, where you can upload a new code and the environment is updated. And you can destroy that branch and the environment is destroyed, completely automatically. Imagine a level designer or game designer that can create environments by their own. They create the environment, tune up the features, and just erase it when they are done. This is a very abstract idea. What do we need to do that? We need fully automatic operations. We need to be completely automatic. We need to create, destroy, and update the environments automatically. We need environment atomicity. That means I don't want to manage different components in different places. I just want to create an environment, destroy an environment, and that's it. We want environment isolation. We don't want to share any more Redis instances in Elasticsearch indexes or whatever. We want the environments to be completely isolated. We need some kind of capacity management. If the environments are created and destroyed dynamically, we need to make sure that one environment doesn't start getting all the resources. We need it to be fast. We don't want to wait minutes to have an environment. We need to have the environment now. We need that this environment is fully integrated with AWS. We use DynamoDB, SQS, SNS, S3, so we have to have the environment fully integrated with AWS. And we have to be able to integrate these environments with our custom applications, configuration, and live-ops management. So, little break here. Obviously, we have to search for new technologies, but we have to make sure we are applying them where it makes sense. We have to avoid hype driver development or hype driver investment. We want to avoid being those guys, seriously. All the technologies comes with a cost. All the technologies causes problems. So you have to make sure that it solves most problems that it causes, because if not, you are doing it wrong. And going back to our containers, to our environments, we need containers. That's obvious. First, we don't want to care about what software we are running. We just want to run some containers, and that's it. But obviously, we need more. We need a layer on top of that manages all of these containers. Kubernetes. Kubernetes is a container orchestration. It's de facto the standard, I would say. And the main characteristics that help us are service discovery, capacity management. It's integrated with AWS, and it's extensible. Let's look at each of them. Service discovery. There is a good thing about services in Kubernetes. If you create a service inside a namespace, all of the pods of this namespace will be able to reach this service just by using its name. So if I create a Redis service inside a namespace, all of the pods there will be able to reach this Redis service just by connecting to Redis. That means that all the environments can have exactly the same configuration if we deploy an environment to a namespace. There is also the ingress controller that it's a level 7 load balancer that allows us to reach each environment just by using a different URL. Capacity management. Kubernetes allows us to specify limits for the containers, but also to set up constraints at the namespace level. So if each environment is deployed in its own namespace, we can set up some constraints there about how many CPU or how many memory it can consume. There is also an add-on called Cluster Autoscaler that can let us to grow or shrink the cluster on demand. AWS integration. Kubernetes, it's integrated with natively. It's able to create load balancers and security groups. There is also a must-have add-on, at least for me, the FT authentication for AWS. It allows to authenticate the users with IAM roles. So you don't have to manage certificates or tokens or whatever. You map an AWS role with an account inside Kubernetes, so the users have the permissions you need to have. Q2EAM, this allows to specify a role for a pod, so a pod have access to some AWS resources without access keys or secret keys. There are also the ALB ingress controller, the application load balancer ingress controller, that uses an AWS application load balancer instead of the Nginx one to make the ingress in the cluster. We are not using it yet because it's not production ready, but in the future probably we will be using it. And the AWS Service Broker, I don't know if you have heard about the Open Service Broker API. It's a standard API to ask for additional resources. What that means? That means that with the AWS Service Broker, you can create a Kubernetes resource that this service broker will map to a DynamoDB table. So you can create DynamoDB tables, S3 buckets, SNS with Kubernetes resources. This is also not production ready, but this is something that we will make use for sure. Extending Kubernetes. There are basically two ways to extend Kubernetes, with custom resource definitions and with API aggregations. Custom resource definitions are much easier, a lot. So if you want to use them, they are really easy. How do you use custom resource definition? Basically, you need to deploy a controller inside the Kubernetes cluster that will listen for events for the resource type you have defined. So you define a resource type DynamoDB or whatever, and you set up a controller that will listen when you want to create one DynamoDB or you want to destroy it. If you are going to use custom resource definition, you should use finalizers. Finalizers allow the controller to make sure that the resource has been deleted in the real world before the Kubernetes delete the resource. That's because if you delete a custom resource definition without a finalizer, the Kubernetes will delete that resource and notify the controller. But if the controller has some problem deleting this resource in the real world, this resource will be there forever. So with finalizers, you can make sure that the controller has deleted the resource in the real world before the Kubernetes can delete the resource. We use custom resource definitions for our custom applications integration and also for AWS resources because the AWS Service Broker is not yet ready. So, hello, no. Wow. No more? Now, environment atomicity. There is an utility called Helm. I don't know if you have heard of it. It is able to deploy charts to the Kubernetes. What is a chart? A chart is a group of Kubernetes resources. With Helm, you can deploy a group of Kubernetes resources and deploy them, completely atomic. So in this chart, you can have pods, services, ingress controllers, and custom resource definitions. So this way, we will be able to deploy a complete environment inside the Kubernetes cluster and destroy it when we are done. Automatic operations. We have developed a custom API that is able to receive with GitHub webhooks and records from the users with our RESTful API. And what it does basically is a wrapper for Helm. To create and destroy, it uses Helm to deploy and destroy the environments. And about the update, this is a bit more tricky. Obviously, the developer needs to update the code that is running in an environment. So basically, there are two ways to do that, with immutable infrastructure or with mutable infrastructure. What does that mean? Immutable. For immutable, if I want to update some code, I have to create a new container, push the new container to the repository, and ask the Kubernetes to do a rolling update over that container. With mutable, we can start from a generic container and put the code inside in an initialization phase. Then we can use a sidecar container to trigger pulls to the repository to update the code. And also, if we use mutable infrastructure, we have to restart some services that are running inside the container. Obviously, both have advantages and disadvantages. It's obvious. For us, it was better to go with mutable infrastructure, so it's what we are using right now. Probably in the future, we might review that decision, but right now is the right decision for us. But obviously, it might be not for you. Well, that's the diagram of the final solution. I cannot use the laser pointer because it ends up the presentation. We don't know why. We have 3 nodes in this diagram running Datadog, Kube2EAM, FluentD to send logs. We have the masters with the FT authenticator running. And on this cluster, we are running the DNAPI. It stands for Dynamic Environment API. Yes, naming things is difficult. And this DNAPI uses the tiller, that it's a pod running inside the Kubernetes cluster, is part of the Helm, to deploy namespaces that contains our environments. We have some CRD controllers to create AWS resources, configuration management resources, LiveOps resources, but mostly that's it. We will now to a demo. That was fast. Where I will show you more or less everything, if it works. So we have already deployed a cluster, so let's make it this. Perfect. I will show what we are running right now in that cluster. This is a simplified cluster, no, it's not the one we use. We have 3 namespaces, the default namespaces from Kubernetes, the default one, the Kube public, the Kube system. If we look what is running in the default namespace, we have the DynamoDB controller. This is the controller for the DynamoDB resources. We have the dynamic API with Redis that it uses for catching some things. And we have the ingress controller, the Nginx one. This dynamic API have a configuration. I'll describe it. Basically, this configuration tells the DNAPI that we are going to push some webhooks from this repository, that it has to deploy the DevOps chart, that version of that chart, and the project identifier is DO, DevOps. If we look at the Kube system namespace, aside of Kubernetes things that are running here, we have the FT authenticator to use EAM roles to authenticate the users. We have the Kube2EAM running here to be able to assign EAM roles to the pods, and the tiller deploy, that it's the Helm part that it's running on the cluster. We look also to AWS. DynamoDB list tables. Okay, we have no any table there. We will create with one. That's one of the points of that demo. So what we are going to do is deploy a chart called DevOps. We have seen that on the configuration, if you remember, right here. And this chart have the main service, the ingress, the DynamoDB table, an Elasticsearch, a web server, a couple of Golang services, and a Redis instance. We will be deploying everything, just pushing a branch to a Git repository. If we look at the code we are going to deploy, it's just a simple PHP. It will get the content from the Golang 1 service and the Golang 2, and will print them, and will report how many nodes are running on the Elasticsearch. We can access also the RESTful API. That's it. Oops, social point environment. Okay, there is not environment green yet. So let's go. Let's create a new branch. Let's call it demo. And we will push demo to our repo. This will trigger. We have configured this repository in GitHub to make a webhook to our dynamic API. So we should see already a new namespace for this. Here it is. Wow, it worked. DO is the project identifier. The demo is the name of the branch. We can take a look at what is running inside. Well, we have the Elasticsearch, a couple of Golang services, the Redis instance, and the web server. There are a couple of pods that are yet initializing. Oh, it doesn't want to work, it seems. If we look at the RESTful API, we'll see that we are deploying the demo, the chart version, the status is initializing. It should be a lot faster. Okay, now it's running. Let's take a look. If we connect now to demo.do DevOps social point test, we are reaching the environment which you've created with the hello world that we printed in the next PHP and the contents of the 2 Golang services. We can now, for example, edit one of that Golang services. I want to change the greeting, for example. We'll say, hey, and if we push this to our repo, we should be able in a, we have changed the greeting. We could change everything. We could change the web page, the Golang service, whatever, and it will be updated. So also there is a DynamoDB table, or it should be there. Oops. So here it is. It worked. So if we finally remove that branch for our repository, we should see that everything is going to terminate. Okay, we see, yeah, it's terminating, and it will be completely erased. And that's it. So, questions? Sorry? Well, I have used the CLI to show it. We have just destroyed the environment, so I think that it will not be there anymore. We can create one if you want. Check out let's call it demo 2, push origin.
That's enough. It's for you to show, because I think this is one of the good things of the demo, that you're creating a custom resource and you're also terminating it.
That's the point now of where I perhaps go too fast. Any other question?
I thank you for your talk. We use also AWS to bootstrap Kubernetes. So what tools do you use to bootstrap the cluster? Why and how many did you try?
Well, I think we tried everything like a year ago. We tried kubeiDM, some scripts that were Kubernetes native, and we are actually using kops. I think, from my point of view, is the best solution right now. We hope AWS makes generic available the EKS, but for what I know, it will take some time.
Okay, how do you deal with the Kubernetes releases? Because sometimes there is breaking change, so the only way to update the cluster is basically a blue-green or a stack swap.
From my point of view, it's better to create a new one, especially for the major ones. The minor ones, it's not that a problem, but the major ones. And because the AP changes, you have to create a new one, test everything is running, look at the documentation to check, okay, let's go to the version 1 of the apps, let's go to the version 2, that was alpha, now it's beta. It's a bit tedious, yes.
Thank you.
Hi.
Hi.
Thanks for the talk first.
Welcome.
You just say that you move to new clusters when there is a new version of Kubernetes. Do you use any tool to move your...
No, we do it manually.
Okay, perfect. Thanks.
So thanks for the talk, very, very interesting and enlightening. As part of the process, do you create that DNS address and the whatever ELB rules that are necessary? And
what we created was the ingress controller, the Nix ingress controller from Kubernetes, that creates an ELB on AWS. And what we have done is create a wildcard pointing to that ELB. So it's new environment, it's a subdomain of the wildcard. So everything points to that ingress controller, and the ingress controller points to the right environment.
And do you have to deal with HTTPS?
Yes, we can use HTTPS. Luckily, the certificate manager from AWS can provide wildcards, so we can use HTTPS.
Okay. Thanks.
More questions?
No more questions? No? All gone? Okay, thank you very much, Luis.
Okay.